Good morning, good afternoon, or good evening. This is Mr. P back again here with your Secondary Math 2 guided notes for section 13.7 of the honors segment, arithmetic sequences and series. Now, you might remember some of this from Secondary Math 1. We'll make sure we do a quick review. So an arithmetic sequence is a sequence in which the difference of consecutive terms is constant. That is, it is increasing or decreasing by the same number every time. And the common difference is how much it increases or decreases by. So the rule for an arithmetic sequence might be the nth term of an arithmetic sequence with the first term a sub 1 and common difference d is a sub 1 plus n minus 1 times d. If you felt like putting that in, distributing that, you could also say a sub n equals a sub 1 plus dn minus d, but I don't think anybody's really interested in that. I would use this one. Well, then why am I crossing it out? Okay. The nth term, you might have an arithmetic sequence, but the first term 3 and a common difference of 2 is, so again, that would be a sub n is equal to your first term, 3, plus the n minus 1, where n is whatever term you're looking for, times the common difference. Now, that's where you might be interested in distributing in there. So 3 open plus 3n minus 2. 3 minus 2 is a plus 1. Sorry, that's a 2n. What am I doing? 2n plus minus 2, 3 minus 2 is 1, so you get 2n plus 1. That's another way of saying it. Okay. Now, here's a funny thing. The sum of a finite arithmetic series, the first n terms of an arithmetic series is s sub n equals n times a sub 1 plus a sub n over 2. Think of it as the mean of a sub 1 and a sub n, and then you divide that by, so you take the mean of those two and then multiply it by how many terms you have. It's kind of cool. Like it actually comes from a fella named Gauss, where he was asked to do this with the numbers 1 through 100. We'll do 1 through 6. 1 plus 2 plus 3 plus 4 plus 5 plus 6. And so we did 1 plus 6 is 7, plus 2 plus 5 is 7, plus 3 plus 4 is 7. So this was really 3 times 7, and that's 21. Now, our friend Gauss was able to do that with the numbers 1 through 100 while he was being sent to the corner for misbehaving. So that's pretty cool. So that's where that comes from. Identify an arithmetic series. Determine if the sequence is arithmetic. That is, we're going to check to see if they are going up or down by the same amount each time. Now, 1 to 4 goes up 3. 4 to 7 goes up 3. 7, 8, up 5. Up 5. No. Not arithmetic. Because the amount it went up by changed. It does not have a common difference. 26 to 23 goes down 3. 23 to 20 goes down 3. 20 to 17 goes down 3. 17 to 14 goes down 3. So yes, this is arithmetic. The common difference is -3. So let's write the rule for these ones. So this goes up 6, up 6, up 6. So in order to do that, we look for a sub 1, the first term, which in this case is 3, and the common difference is a positive 6. We're going to write it 6. Now remember, the rule goes like a sub n equals your first term plus the common difference times n minus 1. Distribute that in there, and you're going to get that the nth term is equal to 3 plus 6n minus 6. 3 minus 6 is -3, and we do a little switching around. So a sub n equals 6 times the term minus 3. And you'll find that's true if n is 1. 6 times 1 is 6. 6 minus 3 is 3. If n is 2, 6 times 2 is 12. 12 minus 3 is 9, and so on. This guy right here, 8 to 3 is down 5, 3 to -2, down 5, -2 to -7, down 5, which means that my first term is 8, and my common difference is -5. That's very important that that's a -5, which means that my nth term is going to be my first term, 8, plus the common difference, negative 5, multiplied by n minus 1. Distribute into parentheses, and the nth term is going to be 8 minus 5n plus 5, because negative 5 times a positive n is a negative 5n. 8 plus 5 is 13, so I get a sub n equals negative 5 plus 13n. Oops, negative 5n plus 13. Yeesh. Very good. A little rusty there, Mr. P. Okay, and you can see that that actually works. Like the fourth term, negative 5 times 4 is negative 20, and negative 20 plus 13 is negative 7, just what we were expecting. Finding the sum of an arithmetic series. So this is terrible, because here's the thing, is that I do not want you to have to do this on 1 through 22, right? Like imagine going 5 minus 2 times 1, plus 5 minus 2 times 2, plus 5 minus 2 times 3, all the way up to plus 5 minus 2 times 22. What a piercing pain. So we're not going to do it that way. We're going to use that formula they gave us, which again is up here. Whoa, I just dropped a clock and the moon just fell off of it. The wife is going to be unhappy with me about that, but the lesson must go on. So the sum of n is equal to the number of terms times the average of the first and the last term. So the first term, 5 minus 2 times 1, is 5 minus 2 is 3. The last term, 5 minus 2 times 22, is equal to 5 minus 44, which is equal to negative 39. So the average of those is 3 plus negative 39 all over 2. And that's going to be 3 minus 39 over 2, which is going to be negative 36 over 2, which is negative 18. Now finally, we're going to do negative 18 times the number of terms, which in this case is 22. I don't have that memorized. Negative 18 times 22, negative 396. And that would be the sum based on the formula. Same story here. So from k is 1 up to 12, we're going to take the number of terms, 12, the sum that we want. I guess we should say sum sub 12 is 12 times the first term, 7 times 1 plus 2, plus the second term, which is, or the last term, which is 7 times 12 plus 2, all divided by 2. Now let's see here, that's going to be 12 times, 7 times 1 is 7 plus 2 plus 7 times 12. You know, you'd think that would be in my memory banks as something that I have memorized, but it absolutely isn't. Also, I keep typing 7 times 1 in my calculator, 84. Plus 2 all over 2. And 7 plus 2 plus 84 plus 2, 7 plus 2 plus 84 plus 2, it's 95, and 95 divided by 2 is 47.5. Now, fret not. I know what you're thinking. How on earth could this be like a decimal? Shouldn't this be a whole number? And it's going to work itself out, because 12 times 47.5 is indeed 570. So when you add all those up, you would get 570. Very good.